Good afternoon, everybody. It is 4:30, 4:34, and I was extremely late to starting this one. Apologies, but we're going to make an attempt to complete Inheritance today. That is the goal, and I think if I complete Inheritance today, we'll take... I'm tempted to say I want to take the rest of the week off, because I'm waking up later and later, unfortunately. And it's making it feels I feel kind of awkward starting stream so late in the afternoon, and not at a consistent hour like I like to. But I'd rather get it completed than not do it at all. So that is the logic I'm working with, I guess, for today, anyways. So today we have four like sub chapters essentially. We have 1 hour of this chapter remaining. We should be finishing Inheritance today. We're at the 25-hour, 26-minute, and 56-second mark. In and Polymorphism starts at 26:21. So we're looking at something like 55 minutes of video time before we start Polymorphism. So that's probably 2 to 3 hours of stream, depending on how this goes. So we got copy constructors with inheritance, inheriting base constructors, inheritance and destructors, and reused symbols in inheritance. Now, I'm not quite sure what any of this is going to cover, because obviously I haven't seen it, but I'm not really familiar with the concepts that it's presenting. Like, copying constructors with inheritance, I mean, I guess kinda, but not really. Inheriting base constructors, I don't quite understand what that's going to cover. Inheritance and destructors, I think, is kind of interesting, but I assume that it's just I assume it just inherits all of the destructors that we have in base classes, but we'll figure that out eventually, I guess. And then reused symbols in inheritance is just I have no idea, not even the slightest clue where that one's going to start. So with that, what we're gonna do is we're gonna continue the video, and it'll be hopefully it'll be interesting to watch. So far, it's all been pretty good. We still haven't been. It still hasn't been explained what this what this O stream syntax looks like or is for. But I guess that's just gonna be something that I have to figure out on my own, I guess. All right. Without any further ado, let's uh let's do this, shall we?
In this lecture, we want to explore how copy constructors work with our inheritance hierarchies. And we will still be using the same example we have been using in this chapter. We will have this inheritance hierarchy, and we will still be using the same example we have been using in this chapter. The base class is going to be person. We're going to be inheriting from that publicly to create an engineer class, and we will be inheriting from the engineer class publicly to create the civil engineer class. And with this, we want to be able to copy construct objects. And the code we want to be running is something like this. We have an engineer object. We want to be able to create another object from this engineer object using the syntax here. And from what we already know, this is going to call our copy constructor. The funny thing is, this is going to work by default even if you don't put in your copy constructor. The reason is the
Oh, so
compiler
a
is going
copy
to
constructor is
insert
its
a
own
copy
thing.
constructor for you, and things are going to be copied in a way that you expect because none of our classes is using dynamic memory allocation. So everything is just going to fall in place and it is going to work. But if you happen to need to set up your own copy constructor, we're going to see how you could do that in this lecture. And we're going to start by the base class. We're going to set up a copy constructor for the person class. And this is nothing complicated. We just pass our parameter by reference. This is going to be our source object. And we will be copying the data from our source object to initialize the member variables in the current object that we are copying here. Again, this
Huh.
is a copy constructor, which will be copy constructing from the parameter that we pass by reference. Now, how do we do the constructor for the engineer class which happens to be inheriting from person. Try to think about that. One way to do things is to set up things like this, and this will be just initializing the engineer layer of our class, but nothing is going to be initializing the person part of us. And this is bad. This is going to call the default constructor to initialize the person part of us, and we will just be left in with junk data that is initializing the person object by default, and all the data we have in our parameter engineer object is just going to be lost for the person part of us. So we don't want to do this. This is bad design. You shouldn't do this. Some of you are going to say, but what if we call the base constructor? We have seen that we could do that, right? But remember, this is a copy constructor. What we have on the left is an object. And it happens to be that if you set up a syntax like this with the copy constructor, the compiler is going to set up a temporary person object and a copy from that object to initialize the person part of us. So this is going to be creating a temporary copy object containing the same data we have in our engineer object. So to some extent, this is going to work, but the problem we still have is that we are using the maddress member variable directly from an engineer object. And from what we already know, this maddress member variable is private to the person class, and we have no business accessing this from an engineer construct. So this is going to give us a compiler error. But you know that it is possible to set up a getter in the engineer class that is going to return this address, and you can call that getter here and get this thing to initialize your data. This is going to work, but this is really weird. You shouldn't do this. This is bad design. There is a better way. I am going to show you. But before we look at that way, let's try and summarize the problems we have with this way of doing things. This is not going to be reusing the copy constructor we have worked hard to set up in person. So this is just going to be code duplication. Another thing is that the maddress member variable is private to person. So if we try and use it like this, we're going to get a compiler error. Again, it is possible to set up a getter that could return that, and we could use that getter in this place, but this is bad design. We are really forced to set up a getter that is possibly only used in this place. That's bad design. We don't want to do something like
you
this.
Don't really want to set some shit up if you're not going to use it multiple times.
Person from which we will be copying to initialize the person part of us. We don't want to be making that copy because we hate copies in C++ code. So the best way to do this is to set up your copy constructor in this way. We are going to say person and directly pass in our engineer object. The compiler is smart enough to see that we are passing an engineer object to initialize a person object. And what the compiler is going to do is really smart. Suppose our engineer object is made up of two layers. The inner layer is going to be containing the information about the person part of us, and the outer layer is going to be containing the engineer part of us.
And then the next part would be
the compiler is going to see that we are passing in an engineer object to initialize a person object, and what it is going to do is really smart. It is going to strip off all this engineer part. If I can describe it like this, we're going to strip off all this engineer part that we have in our engineer object, and we will be just left with the person part that we pass then to initialize our person object. And this is really smart, and it is going to work. So again, the syntax is what you see here. We say person, we pass in our source object, and then we can initialize the member variable that belong to the engineer part of us. We will be initializing contract count, and this is going to work. Now that you know this, we're going to head over to Visual Studio Code and play with this a little bit.
I'm not gonna lie. I was not following too much what we were doing with that. It seemed like he explained, oh, we can do this really simply, and it will work by default without any effort. And then he went through Hey! Oh my fucking god, 1 second. Apologies, my fucking cats are deciding to freak out for no reason. so I have to separate them. But yeah, so it seems like we learned. He basically showed us like, oh, we can do this and it'll work by default. But then he went through explaining why we shouldn't do it that way, or not why we shouldn't do it that way, but why we should, or other ways to do it, to set up the copy constructor, which I think is an interesting. I think it's interesting that copying has its own constructor, but I'm curious how that's going to work. So I guess we just continue.
Copy constructors with inheritance. We will be reusing the code from the last lecture, so we're going to grab everything from that except for the binary, and we're going to copy that and put that in our current project. Let's do this. And we are going to open this bad boy in Visual Studio Code by dragging and dropping here. And we will have our starting point. We will have our person class, the engineer class, and the civil engineer class. And we will just be doing public inheritance to make things easier here. So engineer is going to publicly inherit from person, and civil engineer is going to publicly inherit from engineer. And this is everything we had from the last lecture, nothing special. But
Right.
what we want is to set up copy constructors in such a way that we will be able to build objects from others. For example, if we leave in our engineer object, I think this is what we used in the slides. We're going to have our engineer1 object. We want to be able to create another engineer, let's say engineer2, and build that from engineer1. The thing that might be puzzling to some of you is that this is going to work out of the box even if we didn't really put in a copy constructor.
Okay. Yeah. So he explained that before. So we have our shit done. So might as well. Here. I'm gonna do like this. Create our civil engineer. But then we also can just do. Uh, if we do our civil engineer CE1, and then this should just work. Right? This is basically what he's saying should work. And it should be two different things. So if we do like this, I'm kind of curious if this can just run. Run task, G++. Clear. And yeah, so our CE, it says CE2 here, but this is actually the information in CE1, which is a copy of CE2. So it has all the same tasks, all the same text that we wrote before.
But the thing is, the compiler is going to insert a copy constructor for you, but that constructor is going to be member-wise copy. So it is basically going to be copying things member-wise. It is going to take the contract count from engineer1 and copy that into engineer2, and we are basically going to have the same data from engineer1 in engineer2. Let's try and print engineer2. Can do that. We're going to say end2, and we're going to put this out.
Look at
And
that, we
we
already did
are
it.
going to run the task to build with GCC. That's what we want here. And you're going to see that it is going to work out of the box. If we bring up
Yeah,
a
it's not even a
PowerShell
problem.
window and run Rooster, we're going to see that we have the data in here. We have engineer full name Daniel Gray. That's the data we have in engineer 1. But notice that we are printing engineer 2 here. The age is going to be 41 and the address is going to be exactly what we had in engineer 1.
Yeah,
And
it's
you're
the
going to
same
see
text.
that the constructors are going to be called to set up engineer 2, and the custom constructor for person is going to be called, the custom constructor for engineer is going to be called, and this is exactly what we expect here. But what if we want to set up our own copy constructor? And the need to do that might arise if we happen to be doing some dynamic memory allocation in our classes. Suppose maybe person class has some dynamic memory allocation, it has some pointer member variable, and in the person custom constructor, we are doing some dynamic memory allocation to initialize that pointer. We may be doing the same thing at the engineer level or the civil engineer level, and that will force you to set up your own copy constructor, and we're going to see how you could do that in your classes.
How long did this take? Well, we're currently on the 1 day, 1 hour, and 36 minute mark of the video. I don't know exactly how much time I've spent streaming this stuff because I think I usually take 2 or 3 times the amount of time that I spend in the video per stream, depending on. But yeah, it's a lot of stuff that we've done so far. Hopefully, we can finish in. We're hoping to finish Inheritance today. Yeah, that is our objective. Is finishing this one so we can finally begin polymorphism. Oh man,
We are going to start
it's
with the
so
person
long.
class. We're going to go on top and set up a copy constructor in front of our destructor here. We're going to say
Okay, so we're making a copy constructor here. We have our default constructor, our custom constructor, and now I'm actually going to separate these a little bit just so that I can see them better. So this one will be the copy constructor. I think I was in an earlier chapter when I attempted C++. I mean, I still think I think it's a good video so far. So it's I mean I don't know where exactly you would have been, but it's it makes sense eventually. I think the only thing that I don't like is we had minimal explanation of this friend thing and then this OStream operator, which I don't know how to read this. Probably on chapter 4 or 5. Operations on data and flow control. I know my stream with operations on data got really popular for some reason. It's the man, the myth, the used car salesman. I am not a used car salesman. I resent that.
person, and we're going to say const person reference
Okay,
source.
so
This is the syntax you use to set
person
up your copy
reference
constructor. You
source.
already know this from a previous chapter,
Do we?
and we're
I
going to
don't think
put
I
in
know
the
that.
implementation for this. We're
Also,
going to
Nikki
go
says
in the
konnichiwa.
CPP file before the
Tell Nikki I said hello. So we got
implementation for this. We're going to go in the CPP file before the destructor, or we should go after our custom constructor. It doesn't really matter where you put this.
Welcome to the throne of God, mortal.
I appreciate the follow, Incendo. I hope you enjoy your stay. I'm trying to stay consistent with the C++ stuff, but it is very it's hard. It makes the brain stretch a little bit. All right, so we're looking at the okay, so this is our custom constructor. This is our default constructor. So we probably want to make our copy constructor here. So looking at this person const person source.
And we're going to put in our scope and resolution operator. Let's do person here. And we will just be copying data from the source person. So we're going to put in our initializer list, and we're going to say m full name. We're going to grab the name from the source person. We're going to say source m full name. We're going to initialize the age. We're going to say m age, and we're going to grab the age from the source person. So m age here,
And then we have
and
our
we can go to the
source.
next line so that we see the entire thing here, and say m address, and we're going to say source and say m address. This is going to set up our constructor, and down below we can put in our body. This is going to work, but this is everything we have seen so far. This is nothing new. The syntax to set up your copy constructor, you just pass it by const reference.
I'm actually gonna, so he might do this himself, but I'm going to do this in advance. I'm going to create a little thing saying copy constructor for person called. And I imagine that we'll probably be doing this for all of our subclasses as well. Because we'll have our engineer and then our civil engineer that we can do all of this stuff for. I don't think... I'm not sure. I'm tempted to make an attempt on that here. So that's person. Real quick, I'm gonna go ahead and do a, come to here, just run the task real quick, make sure I didn't break anything. All right, it works. So what I'm gonna do then is I'm gonna come to engineer. Well, this is our header. So we're going to separate these out. Yeah, if I was gonna do those, I should. So we'll have our engineer do like this, but this is going to be just engineer, and then engineer source, and then I don't know how this part's gonna work. All this needs to go away, I think, because I'm pretty sure this is going to be our copy. This one should be our copy constructor. I think this is what it'll look like. And then we come to here. We have our default constructor, our custom constructor, and then this one. This will be engineer, engineer, engineer. Now, I'm not 100% on how this is all going to work. So this one should be copy constructor for engineer. I'm not sure how this is. If we look at this one, we had our person, full name, age, address. But I don't think I can intuit or logic out what these are going to be. What the implementation of the engineer copy is going to be. So for now, I think I'm going to just comment it out. And we'll know whether I did it correctly or not, because we'll be able to we'll still have the text here. I know this is incorrect. This part I'm not even gonna pretend I have any idea how to do it. So that'll be cool.
If you don't pass by reference here, you're going to get an endless chain of copy constructor calls. If this is confusing to you, please go back to the chapter on classes. You're going to see everything about this, and this is really all we need to do here to have a copy constructor for person. Now, let's do things at the engineer level.
Yeah.
We're going to go
Okay,
to
so he didn't actually put in this
class,
thing.
and we need to set up a copy constructor. The syntax is going to be the same. We're going to say engineer, and we will be constructing from a const engineer object we pass as a parameter here. So we're going to say const engineer by reference and say source.
Yep.
And the problem is going to be how we implement this thing. We're going to copy this.
That
and
is
go
the part
in
that I
our
don't know.
engineer CPP file. We're going to put our copy constructor after our custom constructor. And we're going to put in our scope resolution operator. We're going to say engineer, and we're going to put in our body. Let's go below and put that in. If we do things like this, this is just going to initialize our engineer with junk data. We don't want that.
Yeah,
but
we need the
say,
implementation.
I don't know how to call my base constructor, but at least I can initialize my contract count. Okay, let's go back and see if we have this member variable here. Yes, it is called contract count. We can
Okay. So we have our M contract count.
say contract count here, and we are going to initialize this with source contract count. This is going to work, but this is going to call the default constructor of person
Is
to
it not?
initialize the person part of us. And let's go back in our main CPP
and that
file
tells
and
us
see
nothing.
what we are using to try things out. We are building an engineer object from another. Let's try this out and see if our copy constructor is called here. So we're going to say custom copy constructor called for engineer. We're going to put in the message, and we're going to say custom copy constructor, and we're going to build our code.
Did you know Al Capone's business card said he was a used furniture dealer?
to see what happens. The build is
I
going to
did
be
not.
good, and let's see what happens. We're going to clear and run rooster. We are going to see that the constructors are going to be called to set up person 1, but we'll see that the copy constructor for engineer is called. And what I want to do to really make this super clear is put a separator between these two guys. To really know what is happening here, I am going to put in a bunch of dashes just like this. I am going to put in my new line character, and I am going to build again. The build is going to be good. As you see here, we can clear and run rooster. Now we are going to see that the default constructor for person was called to set up the person part of us in our engineer copy constructor. And the reason is we are not doing anything to call the custom copy constructor from person. And let's
Yeah,
go
we
back in
haven't
person
done
and make
anything
sure we are
specific with that.
printing proper information to really see this. When we get to do this right, we are not putting in any method here. So we should do that. We are going to say custom constructor or custom copy constructor called for person.
I'm just saying copy
but
constructor.
This is not called. You see that we are calling the default constructor, and this is going to initialize our person part with junk data. If we print engineer 2 here, you're going to see that the full name is none, the age is 0, and the address is none. So we are basically getting the default data we have in our person object. Let's go back and really show you that. The default full name is going to be none. The default address is going to be none. The age is going to be 0 by default. And this is what we get because in our copy constructor, we're not doing anything to get our custom constructor in person to be called. Okay, so this is not going to work. This is bad. We don't want to do something like this.
So, with that in mind, also I did this wrong. It should be, so this part we have the contract count, and then it should go to source.contract count. So this part does work. This portion, it doesn't do all of what we wanted it to do because it doesn't have the instructions for the person aspect. I wonder if I look at this. I wonder if there's a way we can specifically call the person copy constructor. If I just write the no, I can't just copy all this stuff, can I? I can't just do const person address source. No. 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 I just do, because I think this doesn't work, right? Full name, age, address. This doesn't work, right? Yeah, this is all. This is all not going to work. Because the reason this works is because we're going in here and it's taking the information one thing at a time. There's got to be something that you can do. Because it made perfect sense, I think, when we did the one of these before, where we just had it inherit with like civil engineer. We had it we had it do just the engineer constructor, I think is what we called, and we had it just have all of the information, and then we had our specific thing here, which is our M specialty for this one. So I wonder if maybe there's a way we can do something like that with the copy constructor. Because if we can, then but I don't know what it would be. Think. So we come to here, we have our M full name. This one's our copy constructor. So this is const person reference source. So we don't want to be able to change the person the person reference value. So that's why we have it as a const, and we've labeled that as our source. What if I did... I do person reference? Does that work? No. No, there's no way that works. Alright, I'm gonna keep watching the video.
But let's comment this out and show you another way we might try to do things. And we are going to copy our copy constructor. Let's go down and do this. We're going to put in another copy of this, but we don't want to just initialize our contract count member variable. Instead, we want to do something else. We're going to put a comma here, and we're going to say person. Some of you might be thinking, what if we call the base constructor directly? We can do something like this. We can say person, and we can say source m full name. We can do that. We can say source m age.
Oh, that's right. I need the source
some of you
m.
are going to say source m address. Let's do that. Source m address. And we're going to build a person object and use that to initialize the person part of us. We are basically going to be calling the other person constructor that we have, which takes 3 parameters. This constructor here, this is what we are trying to call in our copy constructor. But as we saw in the slides, this is going to have a bunch of problems. This is going to be creating a
inaccessible
person object that we are going to be copying
from.
No,
this was not what we wanted.
But another problem we have, which is actually going to cause a compiler error, is that we don't have access to the m address member variable from an engineer constructor. And this is going to give us a compiler error. Let's actually try and compile this program to really show you this. We are learning. We should.
It's going to say something about inaccessible in this scope, right? Or private within this context. One of those two.
Errors, and if we go up, we're going to see that our error is the m address member
private within this context. Yep.
To the person class, and we have no business
so we know that.
accessing that in the engineer CPP file at line 27 in our constructor here. And this is going to be our offending line. We can't do this. One could go in our person class and set up a public getter method, which is going to be inherited by engineer.
We could do that, but he talked about how that was already bad.
Let's actually do that to show you that you can do that.
Didn't he say that was bad design?
We are going to go in and put in a public method, which is going to return the address. We actually have that here. So we can call that. We can say source get address. This is going to work. This is going to set up our thing. Let's try to build, because I think Visual Studio Code is messing with us here. Okay, you see the build is good. It is Visual Studio Code, which wasn't understanding our code here. And if we run our program, we're going to see that things are going to work exactly as we expect. Let's actually run the program here. We're going to clear and run Rooster. We're going to see that now the information is being forwarded properly, but we are setting up a temporary person copy, which we are copying from to then forward the data to the person part of us. This is not good design.
Yeah.
And what we really want,
that's what you were saying before,
that is going to allow us to call the copy constructor that we worked hard to set up in our base class here. Let's go back to person and see that. If we go up, we're going to see that we have a copy constructor we really worked hard to set up. We want to reuse this in our engineer class. And that's what we're going to see here. So this is working, but it is not optimal. And we should really try to reuse our code as much as we can. So what we're going to do is set up a mechanism that is going to reuse the copy constructor we have in person. And all we need to do to get that to work, we can say person and then call the copy constructor of person by directly passing in our source object. Notice that we don't need to set up a temporary person object.
Of course!
Directly be copying.
You just put the fucking whole thing in. What? You can just put the whole fucking object in.
From our engineer object, but this is going to do the slicing we saw in the slides. Again, if we have two layers on our object, the inner layer is going to be the person part of us, and the outer green layer is going to be...
Okay, but that means that this is 100% copyable over to this. And we just change some of the numbers or some of the text. And like, what's our new one? It's should be specialty. Specialty. Source dot specialty. No instance of overloaded function for civil engineer called. In some cases, you only want to share certain attributes, but it's possible to share entire objects like that. Well, I mean, it is the copy constructor, right? The idea would be that you would want to... I assume that if you're using a copy constructor, you want to copy the whole thing for one reason or another. And I mean, this is like a custom copy constructor. So what is the issue with this one? No instance of civil engineer. Oh, this is not in my... This should be like this, I think. And does this now work? Specialty. Class engineer has no member specialty. It's not supposed to. Oh, we don't need source. What am I doing for this? This one becomes contract count. That should be const civil engineer. So this should be, I'm pretty sure this is correct. I think this is the correct thing for civil engineer. This should be our correct implementation, and this, I think, is the correct header. Alright, I'm just gonna default constructor. I'm gonna copy this to fucking all of these. Because it's driving, I keep seeing it, and I'm like, I want to label them. But for some reason I haven't been. So we have our default. And we're gonna do custom constructor. And then our copy constructor. And then this is our destructor, which I don't really... I think the only reason we have it is on the off chance we decide to do some dynamic memory allocation. Okay, so now they're all labeled. So if I'm not mistaken, we've jumped ahead a little bit, but I want to make... we're going to watch the video and make sure that I'm not, like, completely retarded. But this should be correct, with any luck.
The engineer part of us. What the compiler is going to do, the compiler is going to see that we are actually passing in an engineer object to initialize the person part of us here. And it is going to see that we just need the red part, we don't need the green part here. The compiler is really smart, so it is going to slice off the outer engineer layer and only leave in the green person part. And it is going to use that to initialize the person part of our engineer object. And this will be reusing the copy constructor we have in our person object. And
And then
this is
this thing
really cool.
actually
This
says
is
copy
the optimal
constructor.
way to set up your copy constructors if you have an inheritance hierarchy. So let's try and build the code again. We're going to pass this through GCC to see if this actually works. The build is going to be good. We can clear and run rooster. We're going to see that the copy constructor is going to be called for.
Oh, hold on, let me see. So if I do like this, so this one should now, so if I'm not mistaken, it'll say custom constructor 3 times for this one, and then it should say copy constructor for each of these things as well. And then it should just print out this one. So we'll call this one, actually no, we're gonna do it like this, but we're gonna just swap these two. CE2 is gonna copy CE1. So we should get 6 lines saying different custom, 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 copy, copy, copy for person, engineer, civil engineer both times, and then it'll print out, it'll be the exact same information, but it should work. All right, let's try. Did I break something? I did. What did I break? In our civil engineer.cpp line 19. This thing. All right, what's the issue here? Oh, well, this is a different line of text, I think. We haven't done this. This one says implicitly declared. Maybe this doesn't work for some reason. What is this? Definition of implicitly declared civil engineers. Here, we're going to do. We're going to cut this out real quick. And we'll get rid of this one for now as well. So I come to here. Does this work? Okay, so that one works. Oops. And we will clear, run this. So custom, custom, custom. Okay, so our customs got called, and then the copy constructors for the two that we have that we know work were called, because these are the person and the engineer we did as we did with the video. So the civil engineer one I've messed up somehow, and I'm not. I guess we'll keep watching to find out what I did wrong. But it has the correct information in it. It has the all this good stuff. So that's cool. That's cool. All right.
For person to set up the person part of us, and then the custom copy constructor for engineer is going to be called to set up the engineer part of us. And if we look at the information we have in the main function, we're going to see that it is the same data. Daniel Gray for the full name, age is 41, address is this gibberish here, and the contract count is 12. It is exactly what we passed here, and our copy constructor is working. Now that we have this working,
I do think it's interesting that even though we did it a little bit wrong, we have something wrong with our civil engineer copy constructor. This still works just out the box. It's just that we didn't write the custom constructor for the civil engineer portion of it. So that's kind of cool.
we can safely reuse the same ideas in our civil engineer copy constructor. We can head over in our civil engineer and set up a copy constructor. So let's do that. We can close the left sidebar here so that we see the entire thing. We are going to say civil engineer, and we want to set up a copy constructor, so we're going to say const civil engineer here, and we will be passing this by
That's right. It needs to
reference.
be
We're going to
civil
say
engineer.
source, and we're going to put the implementation of this
And then
in
this.
our CPP file. We can hop over there and go below our custom constructor.
Does this
We
just
can,
work now?
put in our constructor.
Did I do it correctly now?
Engineer, and put in our scope resolution operator, and we're going to go down and put in the body, and in our
It builds.
initializer list, we're going to call the copy constructor from engineer, because remember, civil engineer is inherited.
Yep, and then we have our
the
custom
engineer
copy
class.
constructor.
So we are going to call the engineer copy constructor.
We did exactly the same thing.
And
So
again,
I made a
this is going
tiny
to
mistake,
slice off the civil engineer
and it
part,
made it so it didn't
and
work, and then
only
we found out
use
the
the
problem.
engineer
Oh,
part
that's a
of us
bummer.
to construct an engineer object from this sliced off engineer object we get from our copy constructor here, and this is really cool. After that,
Okay.
we will initialize our contract count member variable. Oh, it is M speciality if I remember correctly.
Yep.
And we're going to grab source M speciality, and we will use that to initialize the civil engineer part of us here. Let's go in and say that the custom copy constructor is being called.
I wish I had seen that
to say custom copy
myself.
constructor called for a civil engineer. What did we do here? We said engineer. Let's do engineer. This is what we want.
Engineer.
And we're going to say engineer.
You've engined me.
Sorry for this, but this is no big deal. And now that we have this in place, we can actually build civil engineer objects and copy construct them. We can comment out the engineer stuff we have, and we can just put this in a block comment, and we're going to copy construct civil engineers. How cool is that? We're going to set up a civil engineer. Let's do that. And this is going to be a civil engineer, and we're going to say Daniel Gray. We're going to put in all the data, and we're going to specify the speciality to be road strength. This is something I just made up. I don't even know if this kind of speciality
neither do I. Overpass slope, I have no idea.
Engineer object called Ang2
made that shit up,
which we are going to be copy constructing from, and we will see what happens when we copy construct this thing here. We should call our copy constructor in civil engineer, and things should propagate up all the way to the person part of us.
Custom, person engineer civil, copy, person engineer civil.
GCC,
and then it prints out the data in CE2.
So this is good news. We're going to clear and run rooster, and we're going to see that the custom copy constructor is called for person. The custom copy constructor is going to be called for engineer, and the custom copy constructor is going to be called for civil engineer. And you see that things are really propagating all the way to the person part, and we are calling and reusing our copy constructors, and this is really cool. If you go down, you're going to see that the information is printed out correctly. The full name is Daniel Gray, which we have in engineer 1. The age is 41. The address is all this gibberish. The contract count is 12. And the speciality is road strength, and we are properly reusing our copy constructors in our inheritance hierarchy. This is really all I had to share in this lecture. Again, the syntax you should be using to set up your copy constructors is what
I'm excited about that. We did that correctly.
Using the code we have in our upper classes in our
I'm a little sad I didn't catch this tiny mistake where I didn't change this
constructor directly.
But
this is
oh
much
well.
Cleaner. It is reusing code we have in other
This is
classes.
really fucking interesting.
Here in this lecture. In the next one, we're going to see that it is actually possible to inherit base constructors. Go ahead and finish up here and meet me there. In this lecture,
inheriting a base constructor. Now, I assume what that means in this example is that we can have. I kind of assumed that they did that by default, I guess. Because if we look here, right, we have our class person, and then we have all of our constructors in the public setting. So what the hell does it mean that we can inherit it? Like, I assume... I assume that with the default constructors... I mean, they don't... they don't like. Oh, whoops. Like we have a thing saying, "Oh, default constructor for engineer." I guess the fact that they don't call like something specific, I don't know. I kind of assumed that it did do this by default already, but I guess not.
We're going to explore the fact that we can inherit base constructors and use them in our derived classes. We will be reusing the same hierarchy we have been using, so we will have the person class, and we will be inheriting from this person to create an engineer class, and that's what we're going to be using to learn about this concept here. So the person class is what we know from the previous lectures. We have a bunch of member variables here. We have the full name, the age, and the address, and we have a bunch of constructors now. We have a default constructor, a custom constructor, and a copy constructor that we set up tirelessly in the last lecture.
Tirelessly.
Now, what do we mean when we say that we can inherit a constructor? Well, base constructors are not inherited by default, and what we mean by that is that by default it is really not possible to get derived classes to use base constructors to set up things. But it is possible to tell the compiler to use the base constructor to set up our own objects. For example, we can put our statement here saying using person, person. This is going to tell the compiler when building engineer objects, don't use your own constructor, set up a base-like constructor which is going to only initialize the base member variables. And the compiler is going to see this statement and it is going to generate a constructor for you that looks something like this. So it is going to be engineer, it is going to be taking in the full name, the age, and the address, and it is going to be forwarding the work to initialize your object to the person class, and this is all this constructor is going to do. Hopefully you can see that this is called inheriting a base constructor, because all this constructor is really doing is initializing the base member variables.
Wait a second.
Not initializing any member variable that belongs to the engineer class. So the engineer part of us is going to be basically empty containing junk.
Is this not what we were doing? For this, is this not hold on, let me fucking make this smaller again. Is this not this portion of this shit? Yeah, it's just this, isn't it? I guess not quite. Because we have like our... I mean, it's not quite this. Where's my... This one. I think it's this? It's not. It's not part of the constructor. So this is... It seems like it's similar, but we haven't... I don't think we've actually used this. It looked really familiar. I thought maybe it was.
Data that we get by just calling the default constructor, and we will only be initializing the data belonging to the person part of us. This is really what I want you to see. Again, the syntax.
You never use constructor inheritance?
Here. This is going to tell the compiler to generate a constructor that is only going to initialize the base member variables, but this constructor will be callable and usable from the engineer class. Okay, so this is really what we mean by inheriting constructors. One thing you should know is that the constructor is going to be inherited with whatever access specifier it had in the base class. So if our constructor was in...
Wait, what? It's just that? Didn't you see that already? That's what I thought. I looked at it, but it's... So we've used something very similar, at least. What I was looking at... whoops, that was not what I wanted to... What we use something very similar. This is looking at the... what we were looking at before is like the constructor. I think what we did something with like the implementation part of it, we did this part, but it's we haven't actually like done it in the as like the constructor itself. I don't think we actually used the I don't think we ever actually inherited the constructor or used the inherited constructor because I'm kind of under the impression that we have inherited the constructor already because it's in the public section. So it should so like engineer should already have access to it from person because we're inheriting everything is public at this point. And then civil engineer inherits from engineer publicly. So it should also have access to the engineer constructor default or otherwise that we've created. You can get away with that 99% of the time, and it's usually better. It seems. I mean, I'm curious what the use case of it is. I keep saying that with this. It's like my major gripe. One of my major gripes with some of the classes.
The public scope is going to be inherited with public access, so we will be able to use it from the outside and build engineer objects. If it was in a protected scope, we won't be able to use it from the outside. If it was private, we won't even be able to use it from a derived class. You should really know that. So it is going to be inherited with whatever access specifier we had in our base class. Now that we know this, let's see some things you should really be careful about. The first is that copy constructors are not inheritable. If you try to do that, you're going to get a compiler error, but you won't usually notice this because the compiler is going to insert copy constructors for you anyway. This is going to become a problem if you are doing some dynamic memory allocation and you're going to get pointers copied. This is really bad. If you don't know about this, please go back to the chapter on classes and you're going to see all the story about shallow copying and deep copying. We talked about these things. Another thing you should know is that inherited constructors are really base constructors, and what we mean by this is that they will only be initializing the base member variables. Because they are base constructors, they have no knowledge of derived member variables. That's why they only initialize base member variables.
Yeah, like for our examples, like the engineer class contains contract count. The person class, and thus the person constructor has no idea what the hell a contract count or a specialization is.
Again, as we said, the constructors are inherited with whatever access specifier they had in the base class, and it is possible to set up your own constructors on top of the inherited constructors, and you can use these things. Another thing I should really tell you is that inheriting constructors is going to make your code really confusing. It is a technical possibility, but I strongly advise against using this in your code because it is just going to confuse people.
Okay, that makes sense.
People are going to see, for example, an engineer constructor, and they are going to think that that constructor is going to even initializing the engineer member variables. But it's not going to do that because it is a base constructor. It's only going to be initializing the base member variables, and that may lead to some confusion or even really bad problems in your code. So don't use this. It is just going to make things confusing. But I wanted you to
don't use it, but we're going to teach you
and
anyway.
if you see this kind of setup in classes out
I have
there,
never used constructor inheritance.
Know what they mean. This
yeah,
is just
it seems kind of
a base constructor and use it to build objects. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more.
Like this just seems confusing to me. Like I it's like the using the person constructor in the scope of person, and then it has friend. But like, why would you ever want to do that when like we've already shown you can just make your own next one, and you can use the information from the last one. Like when we look at this one. Like, we're already using the information we're forwarding the information to the person class as well. The person class of the given object. So I don't know why you would ever want to use the person constructor. If you are really inheriting a constructor, you should question if you really need to be making derived class in the first place. Yeah, it seems extra. like I say that about a lot of the things that we see here, but like it seems really, really extra for no real benefit. And he even meant like the fact that he even says, "Hey, this is a technical possibility. I'm going to show you how to do it, but you probably don't want to use it." Is an indication of how common it probably is. I think. I imagine it's not a super common thing to explain to see, let alone use.
objects. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current
Are we going to copy
project
all of the information
is
again?
inheriting base constructors. We are going to steal code from the last lecture.
Yup.
And we will be using the main
Dude, we haven't had to
file,
change
the
files
person
in so
class,
long.
and the engineer class. This is just going to be enough for our purposes here. We're going to go back in our current project and we're going to put this in. And we will open this in Visual Studio Code by dragging and dropping here. This is going to give us our thing. And let's go to person and see that we have our constructors in. We have a default constructor.
Not gonna lie, I'm surprised you think that's so strange. A good tutorial should show all the ways you can fuck up with features that seem cool at first glance. I guess. I mean, I think it's maybe it's not strange. I think it's just that it's very it's very trusting, I think is the term that I would go with. It's kind of like I heard an example. I think my dad it told me once. It's like if you look at different, it's probably posted online somewhere. It's talking about like different operating systems, and it's like with Mac your options are fairly limited, and there's not a whole lot of customization or whatever the hell on like for functionality stuff. Windows is a little bit more open, but still very safe, and then like a lot of Linux based OSs give you a rope, a stool, and a tree, and trust that you don't hang yourself. And so this is like looking at a it seemed whenever I see something like this where it's like, hey, this is technically possible. I'm going to show you how to do it. I don't think that you should do it. It's a lot like looking at a tutorial for how to tie a noose. It's like, yeah, it's out there. Yeah, you can technically do it, but you probably shouldn't.
We have a custom constructor.
It's like
and we have a
I'm
copy
grateful that
constructor.
it's there, I
One thing
guess,
you should
because it
know
could be
is that
useful.
copy
It could be
constructors are
useful.
not inherited.
That's the thing.
So you will need to set up your copy constructors explicitly if you want to use them. Note that they won't be coming from the upstream class. You should know that. Okay, so this is the message here. Now, let's look at our engineer class. The engineer class is publicly inheriting from person, and it has a bunch of its own constructors. But what we want to do is to take out all these constructors, and we're going to take them out. I think we can, yeah, we're going to take them out. Let's do that. And we're going to go in.
You should know that Bjarne Strostrup, oh Jesus Christ, has really, really, really quoted phrase, C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. Straustrup. I mean, it makes sense. That sounds like something. It sounds accurate, and based on what based on the fact that during the course of this tutorial, I managed to fucking. I don't know exactly what you would call it, but I fucked my whole shit up and had to restart my computer, in order to in order to continue the stream. I forget which one it was. I sent it to a friend of mine because I thought it was funny. But I could see that happening. All right.
In our CPP file and also take out all these constructors here. We're going to comment them out. I think we can take out all these bad code we got from previous lectures, and we're going to just comment out our constructors. We're going to close them all with a block comment, and what we are going to do in our class is say.
To be fair, I think the quote is fairly outdated, but it's still funny. Oh, it's very funny. I love shit like that. So we're commenting out all of my constructors. Okay. So let's do that. We're not commenting out my destructor, I guess. I assume we're going to do this on other ones as well.
Using and what we are going to do in our class is say using person. We're going to say using person. This is going to inherit the constructor.
Oh, okay, hold on. Let me make sure that I'm...
Bad code with these constructors here. We're going to comment them out. I think we can take...
Okay, I need to go to my CPP as well. So...
out all these bad code we got from previous lectures, and we're going to just comment out our constructors. We're going to close...
Okay. So we will... I think it's all of them. Yeah, it's literally everything. That's kind of insane. So we do like this. Oh wait, is it this one too? No, it's not. This is our output stream thing. These are our constructors. So we've cut out our engineer constructors now.
Close them all with a block comment, and what we are going to do in our class is say using person. We're going to say using person. This is going to inherit the constructors from person. And now that we have this in place, the compiler is really going to generate a base-like constructor in our engineer class. In other words, we're going to have a default engineer constructor, which is just going to not initialize anything. We are going to have a custom constructor, which is going to take 3 parameters, but it is going to be an engineer constructor. And let's prove this. We're going to go in our main CPP file, and we're going to take out everything we have here, and we don't...
Okay, let's see.
Have a civil engineer file, so we shouldn't really include that. And we are going to create an engineer object. We can say eng1. Using the default constructor, we can try and print that out, and you're going to see that this code seems to work in Visual Studio Code. We can try and build this. We're going to pass this through GCC, and we are going to set up a PowerShell window we can use to run and see things. And we're going to see that the default constructor for person was called to initialize this guy. And
all right, let's make sure that I didn't break something, because there's always a chance that I did. We broke something. What did I break? No matching function call for engineer string view. This is in civil engineer. Does his work?
the data is...
It does. What the hell? Oh shit. What did I... Oh. He doesn't have the civil engineer files at all. Okay. Okay, what is my plan here? If I just do... What if I just fucking comment the whole thing out for now? What if I just do like that? I'll just comment these 2 pages entirely out. Just for now. And then I'll get rid of the... And then these should be there. Yeah, okay. So when he copied his stuff, he didn't copy the civil engineer. He just had the engineer ones. That explains why. Okay, so let's run this. Default constructor for person called.
Window we can use to run and see things. And we're going to see that the default constructor for person was called to initialize this guy.
All right, and this is an
and
engineer.
The data is really junk data we have in person. So what the compiler is really doing behind the scenes is to generate a base-like constructor at the engineer level, and it is going to call the base constructor to initialize the person part of us. So the data is just going to be junk data we have in person, and you're going to see that the contract count is going to be 0. This is just a default constructor, which is just going to grab whatever default data we have in our object. You see the contract count is 0. If
Yeah,
we go
the
back
name
in
is
person,
none, the address is none, the contract
full
count
name
is none, the age
which
is
what we
none.
see here, the age is 0, and the address is none. This is a default constructor. But we can even explicitly pass in the data, and that's going to also work. So we can pass in the full name to be Daniel Gray. We can pass in the age to be 23, for example, and we can pass in a junk address, let's say something like this. And you see that this is going to work even if we don't have any engineer constructor. That takes 3 parameters. Let's go back, and you're going to see that all...
Hold on. He just fucking keyboard mashed. Respect.
And you see that this is going to work even if we don't have any engineer constructor. That takes 3 parameters. Let's go back, and you're going to see that all our constructors
That's
are
kind of
commented
interesting.
out, but this is working because we told...
That's kind of interesting that we can, because I don't know if we were able to do that before. I'd have to try it. We'll try it after this, I think. But I think it's interesting that we're able to do. If I had to guess, it wouldn't take it or it wouldn't like it for one reason or another if we tried to create an engineer before, without having all of the variables. It's interesting that you can essentially create an engineer that doesn't actually have the engineer thing or the engineer data initialized.
the compiler to generate a base-like constructor for our engineer. So it is going to also have an engineer constructor that looks like this constructor here, which takes in 3 parameters.
It is initialized. It's 0 initialized. I mean, it's 0 initialized because that's our default thing that we have for it, right? That's our default initialization, but it's not like what I guess I should have said is that it's not changed from its default. It's not like in this case, like an engineer with 0 contracts is not much of an engineer, right? But it's not like like the fact that it has it means it's capable of accepting in some way changing this variable. So like if for some reason you run into something that will increase the count of it, if you try it, you can change the number of it later, but it doesn't actually have to have like more than its default construct. You don't need more than a person to create the engineer. I guess is what I'm trying to say. I'm having trouble wording it because it's very simple, I think, but I'm kind of a moron. Fuck. How do I say this? I guess it's just ready. It is an engineer, but you don't need to have the last thing be the actual engineer variable, the thing that makes it an engineer. You don't have to change that from a default, which I guess would be I've said that like 6 times. I don't know. It feels almost like when you God, video games. It feels like when you've accepted a level, like not like a level in a class or something like that, but like you have a skill that you just don't have trained at all, I guess. Like you're not like you might be in the fucking, you might be like a warrior or whatever, but you don't have any skill with hammer or some shit. So which would normally be a warrior skill that like mages and whatever might not get. Yeah, yeah, I don't know. Maybe that's fucking. I don't know. I'm stun locking myself here for no reason. Let's continue.
And this is really crucial to understand. So again, we are going to set up a constructor for engineer. So it is going to be an engineer constructor, but it is going to be taking 3 parameters just like the person constructor here. And this is the message I really want to convey here. So if we run this code, you're going to see that it is going to work. It is going to call our base-like constructor for engineer, and we're going to have the data forwarded in, but you're going to see that the contract count is not going to be taken into account, so it is going to still contain some default data.
Yeah.
If we try and pass that in, we're going to see that we're going to get a compiler error because now we have no such constructor that takes 4 parameters. The only one we have is one that is generated because of this statement here. And this is going to be a base-like constructor, which is just going to take 3 parameters, just like this constructor here. And another thing I don't think I made clear enough is that this is going to bring in all the constructors you have. Notice that we just put in this statement, but it is going to grab all these constructors we have, except for the copy constructors, which are not inherited in C++. So you should really know this. If we build this code, we're going to get a compiler error because the compiler wants to know what to do with the 45 parameter that we have here. But let's build and really show you this. You need to see this compiler error with your own eyes. Let's go in. So the build is finished.
Here, let's put in our thing. Doesn't really matter what that number is. It should give us a compiler error. So, terminal, run task, and it will give us an error. And what does it say? No matching function call, I think, is the one that he's going to point
errors,
out.
And we have an error saying no matching function call to this constructor, which takes 4 parameters. If we take this out, we're going to see that this is going to work. This is going to use the compiler generated constructor. As a result,
we would need to uncomment our other one, our other custom
now,
constructor.
Build, we're going to see that this is going to work. Okay, the build is good. We can clear and run Rooster. We're going to see that we have the full name to be Daniel Gray. We have the age to be 23. We have our address, which is really some junk data, and the contract count has no data in. It is just the default data we have in our member variable here. We have no way to initialize this from a base-like constructor. But not everything is really bad news. If you don't want to be limited by the constructors that are generated by your compiler as a result of inheriting, you can set up your own constructors. For example, we can uncomment our engineer constructor here and bring it out of our comment. We can do something like this. We can go in the implementation file and also bring this out of our comment section. And now we will be able to use this constructor, which is going to take the 4th parameter.
And it can,
here,
so we have both constructors available.
Now, if we go back in
and then that one would make it so that
parameters is going to work. It is going to use.
That one will make it so that we can accept either 3 or 4. Because I think if we don't have the person one, then we can't do. We have, if we create an engineer, we have to manually put in the 0. Whereas we don't put any. If we don't put anything with it, it should be. If we only use 3 arguments with the engineer, if we don't have the person constructor inherited, that doesn't work because it doesn't match parameter. We don't have anything matching the parameter list. And then with the engineer one that we created that is actually custom, that if that's the only one, then you can't do. Wait, did I say that backwards? The person constructor accepts 3. The engineer constructor accepts 4. If you are missing one or the other, you don't have the constructor list. Or you don't have the one that fits for you don't have one of them doesn't fit. If I create a engineer with only the person stuff that I've custom initialized with whatever stuff that's not like default, like if I then that's fuck, how do I say this in a way that makes fucking sense? Because like it makes sense in my brain, but I'm trying to verbalize it in a way that will make sense to others, and I hear myself talk and I'm not making sense. Engineer has a custom constructor. Custom constructor has 4 parameters. Person has a custom constructor. When the engineer class inherits, or before that, person constructor has 3 parameters. Engineer constructor has 4 parameters. If you try to build an engineer object and use only 3 parameters, you do not have it does not work because it doesn't match the parameter list. You need 4 parameters for an engineer object. If you inherit the constructor, you can use the person parameter list to create an engineer object. It still needs to match the person parameter list. Like I couldn't do like with this, I couldn't do two two integers because this doesn't fit with the parameter list. Or at least it shouldn't. Yeah. No matching parameter list. No matching function call, I think that's the term. Because even though we would have our name and our age, we don't. It needs to match the parameter list in order for us to. Whoops. In order for us to be able to use the number as well, so we would need to put in an address of some sort in order to do this. And we can't. And we aren't right now. Okay.
Use the compiler generated constructor, but if we pass the contract count to before, this is also going to work because it is going to be using our own constructor here. If we build the code, we're going to see that it is going to work just fine. Let's use GCC to show this. You're going to see that the build is good. We can clear and run rooster. Now our contract count is taken into account, and this is really cool. This is really all I wanted you to see in this lecture, that you can let the compiler generate a base-like constructor using the syntax we have in our header here. This using statement can really show up anywhere, but it is going to inherit the constructor with whatever access specifier the constructor had in the base class. And you should really keep these points in mind, especially the last one, that inheriting constructors is going to make your code confusing.
Yeah,
People
well,
are going to notice that they can call constructors that are really not going to be initializing derived member variables, and this may cause serious problems in your code. We are going to stop here in this lecture. In the next one, we're going to explore how inheritance works with destructors. So far, we have been ignoring destructors. We are going to focus on them.
We haven't
in the next
needed to
lecture.
use
So
them.
go ahead and finish up here and meet me there. In this
Okay. How much are we doing? Inheritance and destructors. So we've only got 2 little sub-chapters left, so we only got like 15 minutes of this chapter remaining. So inheritance with destructors. Now we haven't used what should I say? We haven't explicitly called destructors for a good long while now. and I'm pretty sure the last time we did it was something with dynamic memory allocation, which I guess makes sense. But we haven't needed to use them for anything. But we do have them created in case we do need to use them. Uh, I I don't know if that's like good practice or whatever, but it's we definitely have it. So I'm curious how inheritance with destructors is going to go, because like I feel like we covered kind of how destructors would work, because like if we look at some of these. Wait, I guess not. Uh, Basically, it'll when we created like our civil engineer items or objects or other, it would call a person engineer and then civil engineer constructor, and then we don't have the destructors like written in or anything, but I'm pretty sure that it just goes the opposite order where we do civil engineer, engineer, person, destructors. So added to the stack and then removed from the stack in reverse order.
This lecture, we're going to focus on how destructors work with inheritance. And suppose we have an inheritance hierarchy like we have been using all along in this chapter. So
Right.
our base class is person, we have the engineer class which is publicly inheriting from person, and we have a civil engineer class which is inheriting from engineer publicly. So when we create a civil engineer object, we have seen that the base part is built first. So we are going to build the person part of us, we are going to build the engineer part of us on top of that, and we are going to build the civil engineer part of us on top of that. So the constructors are going to be called in this order. We will call the person constructor first, engineer constructor after that, and then a civil engineer constructor after that to set up our civil engineer object.
Yep.
The thing I want you to see in this lecture is that the structures are called in the reverse order to that. So
Yes.
the most specialized destructor is going to be called first, then we're going to destroy the engineer part of us, and the person part of us is going to be destroyed last. So we are going to construct things in this order from the base part to the most specialized one, and then we are going to destroy things in this order.
Yep.
So
Yep.
the
Yep. Yep.
structures
That
are
makes
going to be
perfect
called
sense.
in the reverse order than the constructors. That's the message I want to convey here. And we're going to set up a simple example to play with this. We're going to create a civil engineer object, and we're going to see the order in which these things are called. And let's head over to Visual Studio Code and actually do this. Here we are in
Now, is this just going to be a lesson on the destructor order thing? Because we've seen the destructor order before.
our working folder. The current project is inheritance and destructors. We are going to be reusing the code from a previous
Hello, Arco.
lecture. I don't think the last lecture is a good example because we don't have a civil engineer class. So we are going to go to the lecture before that and use the code from our lecture on the copy constructors with inheritance.
All right, so real quick, we're going to. I think we're gonna go ahead and just get rid of this. Actually, do we need to? No, we're just gonna we're gonna uncomment all of our civil engineer stuff and all of our constructors. All right, so now we have all this stuff. Does this break anything? Kind of curious. Let's try. Make sure it doesn't break. And then if we run it, so it calls our custom constructor for person. Interesting that it's still doing the person one. Okay, cool.
That's going to give us all the classes. We have person, engineer, and civil engineer. And we need
Hope you
that
finish
in
your
this
chapters
lecture
soon, my
here.
G.
So let's grab all these
Soon.
points.
We'll
We're going to
finish
copy them
chapter
and put them
18
in our
today
current
in like,
object,
I mean,
which
there's like
is
15 minutes of
inheritance
this one
and
left.
the structures.
It's not too much.
And we are going to open this in Visual Studio Code, and it is going to be our starting point here. So we have person, engineer, and civil
But then
engineer.
polymorphism is going to be
Let's see
5
what we
hours
are
long by
doing
itself,
in
so.
the main CPP file. We can take out all the junk here, or we can leave in the civil engineer object we are creating.
Will you end
here,
stream
and
by
we're going
then?
to
That
see
will be the
how
intent. I think we'll
the
finish chapter
constructors
18 and then
destructors are called. We're going to go
chapter
to person and
19.
make sure we have a constructor.
I'm not
and we
100% sure if I
have
want
a
to just
bunch of
jump into it
constructors.
tomorrow because look how fucking long it is. It is by far the longest chapter. We go, what is it? So it's 31 hours and 7 minutes long total. It's a little bit under 5 hours of content in that one. Oh man, I have to go for some time, so goodbye. Well, I hope you have a good one, man. There will always be VODs, I guess.
And let's go to the CPP file and see that we have messages in our constructors. This is really what we expect, but we want to also put a message in the destructor. Let's say stdc out and say destructor for person called. This is going to do, we're going to go in our engineer class.
We're going to do this for all of them, aren't we? Person destructor called. And then we do std and line. Come to this. Do engineer. Sorry to interrupt, but what skills did you have before starting this course? Fucking, I played a lot of video games. I knew how to use a file I knew how to go through my files on my computer. I had done very, very little coding like 10 years ago. Yeah, I've very little in the way of actual skills. This is my first coding language. So not much.
We're going to see that we have a bunch of constructors. We have a destructor here. We're going to hop over in the CPP file.
What did you code?
Sure
it was like some Python thing, long time ago. We did it was some high school shit that we did. Basically, I had some program that would like follow your mouse cursor, and that would act as your X and Y coordinate, and that would mean, and what your X and Y coordinate would be related to your it would be related to some animation that I was playing. It was dumb. It wasn't useful. It wasn't really. I had to code Pong at one point, but it was buggy and didn't really work properly. Points, fucking good luck. And the up and down buttons were just not correct for either of them. So not a whole lot in the way of any actual skill. I remember. I think I only passed that class because I was like one of the few people who tried to pay attention to the teacher. But it was not a whole lot. Definitely nothing this complex. Nothing this interesting.
Take out the bad code here because we don't really need that. We only need good code. And we make sure that we have output statements in our constructors.
I'm in high school too.
When
yeah,
they
man.
Are called. Looks like
I was in high school like 10 years ago. Hope it goes well. It's going very well. I hope it's going well for you too, Steve.
This is going to do. And we are going to hop over in our civil engineer class. We're going to have a bunch of constructors. We're going to have a civil engineer destructor. We can
but I mean, if you're in high school,
and make sure that we have
this course is definitely accessible. It's a little bit. It's hard to like for me to force myself to like study. I hated school. but this streaming is how I keep myself honest. It's
output statements in our civil engineer constructors. Looks like we are good here. We can take out all the bad code we don't need. And we are going to put a message in our destructor here. So let's do that. The destructor called for civil engineer.
person
I think
destructor,
this is going to be good enough. Let's
engineer,
go back and make sure we have
civil
the same
engineer.
messages here for engineer. And we have a destructor for person called message. And we're going to try.
Wait, how old are you? You're still in school?
No. Constructors and destructors are
No,
called.
I haven't been in
This is
school
the
in years,
order
dude.
We want to make sure we understand. If you want, you can even use a debugger to follow things, but I am not going to do that here. I am just going to build and show you the output statements. Hopefully.
Here, let's do civil engineer, just so that we can see as many lines of code as we can. I'm gonna call this CE1, and we're gonna do CE1, CE1. Oh, whoops. Did you drop out? No, I didn't drop out. I just never, I did graduate high school, but I never went to college or anything like that. I just went into the military instead. I said, fuck that. And then, I think we called it slope. No, it was overpass slope. That's what I said. That was the one that I was coming up with. So then this should be good. Run task. Clear. Alright, so we have our custom constructor for person, engineer, and civil engineer in sequence. It prints out our thing. And then as expected, our destructor for civil engineer, then person are called in that order. That's pretty good. We're not surprised by this. That we went over this one a while back, but the fact that with the fact that we can just add this stuff now and we know what's going on. I mean, we know how this all works together now. The source code. This is a lot of fucking text.
That's going to be proof enough that things happen in the order that I just described in the slides. The build is good, we can clear, we can bring up a PowerShell window and then clear, and we're going to
I'm in Africa, but how do you guys be able to live with no college degree?
Be called for person, for civil engineer.
Like I said, I was in the military, so I used my military experience to get a better paying job outside in the in the real world, quote unquote.
But you're going to see that destructors are going to be called in the reverse.
Because I wasn't just a infantry guy. I went into like some
first.
other shit.
Then we're going to call the destructor for engineer. Then we're going to call the destructor for the base class. So things are going to be happening in reverse order. We will build things starting from the base and then finish by the most specialized class, which is doing inheritance, and then we're going to call the destructor for the most specialized class first, and then
the
civil
engineer
for the most base class is going to be called last. You should really make sure you understand this, because sometimes your things are going to be depending on this order, and you need to understand this, and this is really the main message here, that destructors are really called in the reverse order than the constructors. We are going to stop here in this lecture. In the next one, we're going to see that we can actually reuse names in our inheritance hierarchy, and we're going to see how that works out in the next lecture. So go ahead and finish up here and meet me there.
Alright, so then this is the last part of inheritance by the looks of it. I'm curious how this one's going to be. This one should be pretty short by the looks of it. We're looking at like what? This one's only 9 minutes long, which is really, really short for one of these sections, especially since inheritance. This one was like 2 hours for me, and I spent, I think it was like 40 minutes of actual video. We're getting close to the end of the chapter here. I don't know how much more stuff we're going to have to do. Where can I join your community or some Discord or your community with your people? I don't actually have anything like that. I haven't made a Discord or anything because I'm very lazy about updating even my YouTube channel, so I don't want to make a Discord and then suddenly have people expecting that to be actually used. I feel it's better to temper expectations in that sense. I mean, if you subscribe, I try to do streams. I try to stream daily. It doesn't always happen, but I try to do something. I have like gaming streams at night. Like that'll be in like 5 hours and some change. No, 4 hours and 45 minutes. All right, last section. Let's do this.
In this lecture, we're going to see that we can reuse names in our inheritance hierarchy. And what we mean by that is that we can have a parent class, for example, and have a child class inheriting from the parent class, and have exactly the same names for the member variables and types, or the same signatures for functions. For example, in the parent class, you see that we have a member function called printvar. It is going to be printing some information. We can have a function named exactly the same in the child class, and C++ is going to allow this. We can also do the same things for member variables. For example,
then how do you communicate with your online people?
Type int.
In my streams,
exactly
and I have community posts now and then if something's delayed.
is going to allow this. Now, the problem is,
or if
you
I'm
create
canceling
an
for the
object
night.
of child, which method will be called if you call printvar? Now, what C++
I don't exactly
does
make money
is
doing
it
this,
is
so
going to override or hide things you have in the base class if you happen to set up exactly the same thing in a derived class. So for example, the members in our child class are going to hide the members we had in the base class, and if we call these methods on a child object, we are going to get the versions in the child class called. If we call these methods on a parent object, we are going to get the parent version called, and we're going to see the data in the parent class printed out. This is the message here. It is possible to use the same names
that seems
in
a
both
little bit
parent and
confusing.
child classes, and if you do
What
that,
is
things in child classes are going to hide or override what we had in the parent class. This is the message I want to convey here. And here is a simple example to drive home how you can use these things. For example, we can create a child object using this syntax here. And if we call a method on the child object, this is going to call the method in child. But it is possible to force the compiler to call the version in the base class. And you're going to see this syntax used somewhere in your code out there. So the syntax is to say the object name, you put a dot, you say the name for the parent class, and then you call the method using the scope resolution operator here. And this is going to call the method in the parent. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our
I'm curious why you would
working
want to do
folder.
something
the
like
current
that.
project is reused symbols in inheritance.
All right, let's make this smaller. I wonder if we'll actually if I finally have to make a new file, that would be kind of funny, I think.
We are going to just grab the template files because we are going to be building things from scratch here, and we're going to put in our files. No big.
All right, let me open this real quick. File, open folder, and go to, I think we're in project 51 now. Look at that, we have our no scuff here. Nope, not once, not ever.
Big deal here, and we can open this in Visual Studio Code. This is going to give us a bare minimum main CPP file. We can clean it up a little bit, and we're going to set up our parent class. Let's do that pretty fast. We're going to say parent and set up the header, and we're going to set up the implementation CPP file. We are going to set up the header file, and this is going to do everything we want. We have a constructor which is really defaulted here. So
okay, so he just gets to copy all that in, but I have to actually write it. So that's always great. So we're creating a class called parent. So in our public, which it is by default, but we're doing this for readability. We have a default constructor. We have our int member variable. Member variable. Member var. This one I'm actually not so sure about. This seems that seems like a weird constructor, I think. And then we have our void print var, and we're doing const. We have our spitting out to the terminal. We have the value in parent is. Then we have member variable end line. And then we're creating a protected section, which will have int m member variable initialized to 100. For real, your streaming is calming as fuck. Keep streaming for another time too. Subscribe to. Hey, I appreciate it, man. Thank you. I enjoy just kind of hanging out. I try to be very relaxed, because if I get stressed, then it stops being fun. Parent h.
So let's say default, and we can default the
Actually, did you
CPP file.
do
We
my
are going to set up
thingamajig?
the header file.
I can't see the top thing. I assume it's the if and def shit that we saw before.
And this is going to do everything we want. We have a constructor which is really defaulted here. So let's say default, and we can default the destructor. Can we default it? Let's do this and see what happens. And we don't really need to do anything in the CPP file. We can leave it empty. This is not
I don't know if do we need to default any of this stuff? I think we can just do like this. This is what we had it as before.
not going to hurt anything. And with this, we can create parent objects. Let's do that. We're going to hop over to the main CPP file and include parent and make sure that we can use that. And we're going to create a parent object. Let's do that. We're going to say parent p1 and say p1 print values. We can do that. And we can build and run this program. I think it is going to work just fine. Okay, the build is good, we can clear, or we can set up a PowerShell window and clear and run rooster. This is going to say the value in parent is 100, which is what we have by default here. We have a simple member variable, which is
okay, yeah. It's something to do with the if and def. Define. I can never remember what that stuff is supposed to look like. Kind of hoping he'll just show it here soon.
It is protected because we want it to be inherited, and we have a bunch of constructors here. We have a constructor which is
Got quiet, Sensei, please.
Use that here.
Scroll up.
Is just fine.
Scroll
you can
up.
Use that if you want, and we have a member function which is going to print the value in parent. Now that this is working, we can set up a child class which is going to be inheriting from the parent class here. So let's do that. We're going to set up the child header file, child.h, and we're going to set up a CPP file for that, .cpp.
Oh man. Okay. So we'll do child.h and child.cpp.
So we are going to put the data in the header file. Again, it is nothing complicated.
Okay. So we're going to, this is parent underscore h, and then we also want our what is it? It's if and def parent underscore h, and then when we do child, we're doing if and def child underscore h define child underscore h, and we are including parent.h. Nice. You got lucky now. Yeah, I did. Fucking hell. I I know it's supposed to be something like this, but I can never remember what the include guards look like. I think I was told essentially like a cheat, not really, but it was a way to kind of bypass it before that I don't remember what it is. It's something to do with pragma once. So we have our public, creating child. This is our child constructor. This is our child custom constructor. Int member variable. Then we have our member variable, boom, boom. And then our child destructor. Hello, friend. How you doing, Tara? I'm gonna make banana bread. Nice. Syntax are also hard to keep in my memory. Syntax is one of the things that I'm gonna struggle with probably forever. Just trying to remember how to say all these different things to the C++ compiler so that I can actually do what I want. What I need to do, what I kind of want to do, is try to actually make something myself before I even go to the next chapter. But I'm not actually sure what I would do. I think a friend of mine said to make Minesweeper. Minesweeper in C++. I'm gonna add chocolate chips to do it if I have. Oh, nice. That sounds delicious.
It is just a simple class which is going to be inheriting from parent, and we are going to have our own member variable which is going to eclipse what we had in the parent. So the names here must be the same, member var. If we go in parent, it is member var, and what we have in child is going to eclipse what we had in the parent class. In other words, if we print the member variable in child, we're going to see 1000 printed out here. We won't see 100 that we have in the parent.
Oh, wait. I did not create the protected thing, did I? I did not. Okay. Protected. And then this one's int member variable. And then this one should be 1000 for the child. Parent has 100. Is child including IOStream? I don't know. I like using this face in my JP pen pals. Nice.
Printed out. Hopefully this is going to drive the point home that if you have...
If I don't bother you, would you make a walkthrough like this for a book, or is it forbidden to post a book here on YouTube? I've never done anything like that. I mean, this is available on YouTube for free. Like, this is just on FreeCodeCamp's YouTube channel. So this is 100% available to anybody. And I don't know, I'm certainly not good enough at C++ to actually summarize this any better. It's kind of like, this is about as it's fairly thorough. I'm not so sure how good it would be, or how good I would do it. You can do book stuff on YouTube. People do it with the JLPT textbooks. Do they? That sounds like you could get in trouble. Yeah, but I don't know anything about it. I haven't done anything like that. This is probably, if I was gonna get in trouble for like stealing content from somebody, this would probably be the series that would have it happen to me. Because I had one guy post a comment saying like, dude, if I want to see Daniel Garquaya's video, I know where to find it. And I'm like, okay, but that's not the point. This is me streaming, learning it, man. I don't understand what I'm doing.
Have members named exactly the same, What
Oh wait, okay. So value in child we have this thing. The value in child is we also can do std cout. The value in parent is, and then we do in the scope of parent, that's our scope resolution, and then we look at this member variable. I don't use textbooks, so I don't know how effective it is. No, I meant like, would you make a walkthrough for a book? The book is interesting, though, I'll tell you. I've never. I don't think I've ever made a walkthrough for anything, or listen, like read the book on stream. I considered doing some stuff like that a while ago. I considered just reading a bunch of fucking like Elder Scrolls books. But I haven't ever done anything like that just explicitly to like read it out. I mean, I've done a decent amount of like reading and stuff on stream for stuff that I find in games. I think that's pretty fun.
you have in your derived classes is going to eclipse or hide what we had in the parent class. This is the message here. But even if this is the case, C++ allows us to specify that we want.
Wait, I'm a fool. I did this incorrectly. This is print var. This one we want to be show values. We're going to go ahead and just recreate this. Void print var. And then this one's going to be const. That is not what I wanted. Const. And then this has, I think it's just this one. Deus Ex read along with Denton and friends. I read so much in like the first thing of in like the first stream of Deus Ex. I read like every book that I could find. Okay. This one has just print variable. This one I don't think parent has the show values one. Do it for Black Hat Python book. You won't regret reading it. Black Hat Python, huh? I'll look into it. I can't. I don't want to make any promises about anything, but I'll look into it.
To grab the data in parent from a child object. For example, in our show values method, we can print the value in child directly using mmembervar, but we can also specify that we want the value in the parent class, because even if this is a child object, it has a parent part of it. So we
We've
can
inherited
access
the
the
parent
data in
data.
parent and print that if the data happens to be accessible from our derived class. And that's why we set up our member variable to be protected, for it to be accessible in our derived classes. This is going to allow us to print something like this, and this is going to really work. Now that we have this in place, we can go in the main CPP file and only include the child.
Did I? Oh, there's two of these. Is this fine now? Let's see. Terminal, run task. What does this do? Undefined reference. Class child defines member variable with the same mmember var as defined to parent class. Oh boy. So this is parent p1, p1.print var. So that this should be, oh, include child.h. What about now? Finished with errors still. Oh no. No problem, Bo. I won't stress you. Alright. I appreciate that. Now I'm kind of confused as to what I've done wrong. Alright, let's go back through.
But we can look.
We're gonna attempt to run it again. We'll see what the error is. But I think I need to go backwards and look. Undefined reference to parent. So we're looking at an undefined reference. This is blank, this is blank. Function definition for parent not found, huh? Class parent constructor with one argument that is not explicit. Alright, I need to go back to the parent when he's building that.
We have in child.
It seems like every time I go.
That's what we had allocated. So .h.
Okay, so we're looking at parent now. We have our class parent. Maybe if I just do. Let's make our stuff look like his. Default. There we go. Default. And here we have void print variable const. And we have our member variable std end line. Come to here. Protected int member variable 100. And then we have our end if. So this should be good. This looks the same.
So let's do that. We're going to set up the child header file, child.h, and we're going to set up a CPP file for that, .cpp. So we are going to put the data in the header file. Again, it is not.
All right, so this, we have if and def child h, define child h, include parent.h, class is child, publicly inheriting from parent. Then we have here public child, our default constructor, child int member variable. We have member variable. So this is if we're doing something manually, I guess. This is our child destructor. Then we have our void print variable. I need to try to back up a little bit. We have our destructor, a void print variable const, stdcout, the value in child is, and then we have our member variable, and we're ending line, showing values command, or member, what is it called? It's a word. It is 1:34 a.m. I'm going to go to sleep, or I can go all nighter. My alarm is set for 5, and it's the first day of school. Oh no, man. Good. That sounds like it'll be stressful. I hope you, I recommend getting some sleep. I don't recommend doing an all-nighter the day before your first day back. What did you guys cover this time? This time we were doing a little bit more, I mean, it's more inheritance stuff, but we talked about inheriting constructors. And we also looked a little bit at the destructor again. But I'm not sure what I've done wrong here.
It's nothing complicated. It is just a simple class which is going to be inheriting from parent. And
now it's successful.
Our own member variable, which is
I guess it was literally just this.
The parent. So the names
just
here
this
must
default
be the
thing.
Same member var. If we go in parent, it is member var. And what we have.
I had a dream about some ghost house, and the plot was getting good, but then I woke up. Oh no!
The parent class. In other words, if we print the member variable in child, we're going to see 1000 printed out here. We won't see 100 that we have in the parent printed out. Hopefully this is going to drive the point home that if you have members named exactly the same, what you have in your derived classes is going to eclipse or hide what we had in the parent class. This is the message here. But even if this is the case, C++ allows us to specify that we want to grab the data in parent from a child object. For example, in our showValues method, we can print the value in child directly using mmembervar, but we can also specify that we want the value in the parent class, because even if this is a child object, it has a parent part of it. So we can access the data in parent and print that if the data happens to be accessible from our derived class. And that's why we set up our member variable to be protected, for it to be accessible in our derived classes. This is going to allow us to print something like this, and this is going to really work. Now that we have this in place, we can go in the main CPP file and only include the child. We can do that, and we're going to create a child object, or we can just take out everything here and just put in the code we can use to play with these things.
Oh my god. Of course he just copies in a bunch of stuff. Dick! Alright. We'll do a child called child, initialized at 33. Child.print var. That is way more than I was expecting. So this should call the child method. Oh, we didn't have this. So this calls the method print variable in the child thing. So then here we do child.parent, and this will do the version that we have specially designed in the child class to print the variable, or the member variable in the parent class. So this one, this is just an empty line, so we're just gonna should probably just it always does that, and like so. God damn it. There we go. Do you use TikTok? I do not. I know a lot of people do. I had a TikTok account once. I had a few videos on there, but I haven't been able to access it, and and last I checked, it doesn't exist anymore. So I don't know what the hell happened to it. I was I guess I was banned or something, but I didn't get an email saying I was banned, or I didn't get anything saying, "Hey, your account is locked." So it seems like my account was just deleted or doesn't exist anymore. Orphan a child so Harry Potter can be born. I don't want to do that. All right, we'll do this. Oh, it broke again. The mystery of the great mystery of the TikTokening. Oh no. What is it talking about? In function main, undefined reference to child. Are we sure? It doesn't look like it's undefined. I'm in the child. It includes parent. We don't have anything in the methods. I'm curious what I've broken here. Function definition for child not found. Default? Maybe? Maybe I do this for these as well. Default. Let's try that. Yeah, okay, that works. I don't know why that works. Should I stop TikTok too? It just takes time, plus it's time for school, but I don't want to miss out on things on TikTok. It's probably best if you don't use TikTok. It's generally best if you focus your efforts towards productive things. But you don't want to cut out all of the stuff that is not you don't want to get rid of all of your downtime stuff. So I don't know. That's kind of the work-life balance, right? It's a difficult it's difficult to I think. Well, it's difficult to know what's best. I mean, you probably don't need to like uninstall it, get rid of it completely, but you also probably don't want to let it like consume your life. So, oh, that's not. I did not want a robocopy. I wanted rooster. So value in child is 33. Value in parent is 100. And then this one has these two. Interesting.
We can create a child object, and on
Social
this
media is a
child
waste
we
of
can
time.
print a
Yeah,
var.
but
We're
it's
going
so
to
much
see
fun
that the
though.
data is going to be printed out, but we can also use this syntax to print the data in
I
the
mean, this is
parent
social media right
part
now.
of us, and we're going to see that the data is printed out. We can also show the values and make sure we see this from a member function of the child class. This is going to call this member, and we're going to get the value in child, and we're going to get the value in parent printed out on the console. Now that we have this, we can actually try and build this. We're going to use GCC to do that. We're
And it
going to
should
see that
do
we're going
exactly the
to
same thing that
finish
I did.
building with errors. What is the problem here? We have an undefined reference to child destructor. We didn't put in a definition for the child destructor, so let's go there and default it.
Yeah,
We can do that.
we
We're going
defaulted
to say equals
everything.
default, and the compiler is going to
Okay, so
generate
he
one
had the
for
same
us.
issues we did. Thank God.
And now if we build, we're going to build with GCC again. The build is going to be good. You can clear and
I want
run
to do things
Rooster,
like you
and
instead
we're
of
going to see
scrolling
that the value in
24/7.
child is 33 because we passed that in.
I mean, if you're talking about stuff like this, I mean, this is like self-study essentially what I'm doing. So, I'm using streaming to keep myself honest and force myself to actually do it. So if that's something that you think would work for you, then then I recommend doing it. But this ultimately the purpose of this is to improve myself. And if there were 0 people watching, I would still be trying to do the same thing. I would be trying to stay consistent on doing this and like recording my progress. And it's helpful, at least for me. I don't know if that would work for everybody, but for me at least, it's like, okay, I know that I'm doing this. This is the plan. I've set an agenda for myself. I have a goal. And now I just need to make sure I actually make effort towards that goal. And this is how I do that.
Explicitly, and this is going to call the constructor we
Yep.
have in child.
His thing
that happens to be
looks like
this
mine.
guy here. And you see that we are really keeping things simple. We are not calling the base constructor here. The compiler is just going to call the default constructor we have in parent here, and this is going to
This is why I
just
love
work.
you.
The
Appreciate
main
it, man.
message here
Thank you.
is that you can set up member variables and member functions named exactly the same way in the parent class and in child classes, and what you have in your derived classes is going to hide what we have in our parent classes. So if we call a method on a child object, for example, like we are doing here, this is going to call the method in child, but we still have the ability to call data in the parent part of us, and this is what we do here.
Yep.
I would like to welcome...
Okay. Well, that was a sudden ending to that chapter. So, that marks the end of chapter 18. And we are now into the final stretch. Polymorphism. Now, I don't know a whole lot about polymorphism, but everything that I've heard is that it's one of the more complicated concepts from what I understand. So let's see. Let me open up this will be where we call it. I'm going to spend a couple minutes talking about what I expect from this going forward, so see if I can maybe look back on what we thought we had. So now we're looking at, it's 26, 21, 03, and we're finally beginning polymorphism. So polymorphism, from what I understand, is treating objects as members of two different classes or some shit like that. Now, I don't know this for sure. Everything that I'm saying here is off of things that friends told me that I may or may not be misremembering. And so this is not like me teaching. This is me thinking I understand. This is the this is like one of the harder things that I think is going to happen. So my understanding, the way it was explained to me, is that uh, a square as an object is both a shape and it is specifically a rectangle, right? You can treat it as members of both of those things. Like a SUV is like an extension of like a vehicle or some shit. So I'm hoping this will make sense when we inevitably do it as part of as part of the course. I mean, was up to this point the longest one. It seems like a lot of the stuff that we did early on, I didn't actually stream chapter 1, but streaming from chapter 2 onward, because like things like comments, errors and warnings, all this stuff that we picked up, all of this feeds into initially so far it's been like these two classes, these two chapters. All of them are things that we do to make this stuff make sense and make it like more than just like, oh hey, this is what a class is and here's uh like it's understanding all of the different parts. It feels like functions were another one that were kind of big. Function templates I'd like to learn more about. I'd like to this was an interesting thing that we did. But now we're finally on this one. I'm gonna need to start looking into like uh probably like some sort of qualification that I can take a test for. Probably nothing like huge, but I want to see if the skills that I've learned have been maintained over the course of this course. Over the over this time period. And B, I want to I want to try and make something myself. Maybe something simple. I don't. Um, since we finished such a big chapter, I'm tempted to. I'm not gonna lie. I am tempted to try and hold off and start chapter 19 on Monday. But that would basically be committing to doing all of chapter 19 over next week, which that would be a little bit under 2 months. I think it's 7 weeks total that I've spent doing this. I think I started August 1st. That's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yeah, so tomorrow will mark the 7th week, and then doing it, uh, doing the rest of it over the course of next week would make it an 8-week course essentially. So that's pretty quick, I think. So yeah, I think what we're gonna do, we're gonna call it here. We'll do C++ again on Monday, I think. That would be and we'll work polymorphism will be like the thing we are doing next week. Because this is a pretty major thing that we've got. So we'll be prepared for that. I'm gonna see about I'll try to do something else with C++ over on like Thursday and Friday. I don't have that. I don't have anything specific in mind. I'm going to talk to Lazy and see if maybe he can give me an idea, something I can try to do in one stream. Try something I can try to make to try to make sure I understand and have actually maintained my understanding of all the different things. So we're gonna go ahead and close all this stuff. All right. The stamps on the pen pal app are making me want to make veggie stamps. That would be so cute. I want to get some emotes so that I can. I want to get emotes one day so that I can have a few custom things. That would be nice. Anyways, guys, it's been a good time hanging out with you guys. I hope you guys had a good time hanging out with me as well. We're getting closer to. It's like almost 7 p.m. where I am, so I'm going to hop off. I'm gonna probably get some food, hang out a little bit before I do my before I do my gaming stream tonight. We're playing. It's Weeb Wednesday, so we're gonna be playing some Xenogears. That'll be fun. And uh, until I guess on Monday we'll continue with polymorphism. I'll get back. You'll see a community post from me when I know what the project should be for like tomorrow and the day after. I don't know if it'll be too. I don't. I want to make it so that it's like a 1 or 2 stream kind of deal. Uh, but we're not going to be. I don't want to put off doing any C++ for 4 whole days. So so yeah. Love you, bro. Thank you. Thank you. Love you guys. I'll see you again in a few hours with some Xenogears. Bye. Thanks for hanging out.